is on.
Hello! Welcome to Cosmos with Cosmos live coverage of the Superb Owl. Number 57. I don't know. Okay, I don't. Can you imagine if we did a sports covered episode?
We gotta do it.
We're gonna do it. Okay, let's tune into the... Wait, we don't have any channels, cable that get the super... Oh, it's probably on like a streaming. It's probably on like Amazon.
You know, what we could do is we could just recap Ireland versus Italy's rugby match today.
Okay, yes, the people want to know about the rugby.
Federico does not want to know about that. It was a little brutal.
I guess pasta beats potatoes.
Potatoes beat pasta.
I meant potatoes beat pasta. That's what I meant.
Yeah, no, it was brutal for Italy.
Although, is gnocchi potato or is that a pasta?
Oh, I don't know.
Because I thought gnocchi was like a potato.
You're the chef.
I'm not that
Pierogies are potato.
Pierogies are potatoes, yes.
So.
Yes. Anyway, hi! We're here. We're live. We're back.
For now, we're live. I mean, the internet might go
Yeah,
out.
I know. Who knows? It was raining earlier, so I just expect the stream to die, but we'll try and get it back if it does. Anyway.
Or we just go put Legos together.
Okay. Sorry, you got like just fuzz. Oh, they can't see it on the camera, but it's fuzzy. You're fuzzy. Well, you're leading this party, so I'm just letting you know that you can get it going whenever you want.
Hi, everyone. Welcome to Cosmos with Cosmos. As always, I'm Mike.
I'm Liz.
And today we're talking Vera Rubin.
Vera Rubin.
Finally doing it.
If you are a fan of the pod, if you've listened to a good a good chunk of episodes, then you know Vera Rubin has been brought up, and Mike's gone on soapboxes about her. He gets very excited to talk about Vera Rubin. So it is the Phancy Physics Man Geek Out Vera Rubin episode.
I have strong opinions on one award that she should have received.
Yes.
But I'm not the only one. Others have very strong opinions as well. But so we're going to take a look at the life of and discoveries of Vera Rubin today. Before we do that, Liz, what are you drinking?
I'm drinking what you're drinking in honor of Vera Rubin. We're drinking the Rubin.
The Rubin.
So, Mike, tell us what's in the Rubin.
You know what's in the Rubin?
It's basically a Moscow Mule that's purple.
Yeah, so it, with all Moscow Mules, you have lime juice, vodka, and ginger beer. I was gonna say butterbeer, but that's not the.
Except yours, I wonder if they can see. You have a cute little.
Oh, you have it too. I put one in yours.
Well, it just looks like a square blob. Yours actually looks like a little spaceship.
I think yours was a planet.
I'll just
you had to take it out.
It's a little spaceship ice cube.
So what gives it that blue ice cube color, but and actually the purple color as well, because it's a magic tea, is
magic.
Oh, it's butterfly pea tea. And so normally it is blue in color, a nice rich blue. But when you put it into when you include something like lime juice, it turns purple.
Ah, and that is what's called chemistry.
It is chemistry,
hey.
Yes, indeed.
Jack, you had ads? 2 unskippable ads? Really? I feel like we should get some kickback, some money from that. YouTube's, but we don't.
Where's our? Yeah, where's our?
We don't qualify, I don't think, for.
Oh, that's not cool. Anyway, follow us on all the things. Speaking of YouTube and social and all that kind of stuff, follow us on all the things. Cosmos, except for on Twitter. Twitter, it is Drinking Cosmos. So follow us on that. Rate us on everything. And of course, don't forget to join us for The Hangover, which I have no idea what we're going to talk about. I think we'll just shoot the breeze. Probably talk about Super Bowl. I don't know.
Because we know a lot about the Super Bowl. All I know is the Niners are in it, and being a Bay Area gal, then I'm pulling for the Niners, obviously.
They play the Chiefs, and that's really about all I know. And it's Super Bowl 50-something.
Oh, I was right in the 50s.
Well, I think it's 50-something.
Oh.
And so that means 50 to 59, somewhere in there.
Yeah, okay.
I think Usher is the halftime person. And if you follow...
Halftime person?
Yeah,
if you follow... halftime person.
But if you follow all the conspiracy theories... Taylor Swift is going to come out at halftime with her boyfriend...
Travis Kelce?
Yeah,
whatever.
One of the Kelce kids. And they're going to endorse Biden for president.
Okay.
But that's if you believe all the hype.
Ooh, Jack's got a plum tea in honor of Lunar New Year. Yes, happy Lunar New Year. Year of the Dragon.
Year of the Dragon. Did we just start a war with China on it?
No, I don't think that that dragon impression was that offensive.
No, but happy Lunar New Year to everybody. The Year of the Dragon. And of course, go to Wildixia on Etsy. Go to Etsy and check out Wildixia. Ixia, god damn it.
You okay?
No,
are you fine? How much Moscow Mule did you taste to...
I only had one sip of the Reuben. Anyway, go to Etsy.
Wildixia.
Yes.
Check out her shit. She draws cool shit.
Check out her great art that she has there. Also, check out Ron Proctor at MrProctorShow.com, and where he talks about, education. He also is down... he's down in Tucson now, right? What?
I don't know.
I think he's down in Tucson.
Yeah, but then he was hanging out up in Ogden. I don't know. He's a worldly man.
Yes. Also, if you are in the Council Bluffs, Iowa area, check out Jack's Planetarium, Rolling Bluffs Planetarium. You can find out more about them at rollingbluffsplanetarium.com. Liz and I saw a show about stalking yesterday, and part of it takes place in
Council Bluffs, Iowa. We're like, Jack!
And we knew. So we saw a little bit of a... Jack wasn't the stalker.
No, or involved in any way.
Also...
Yeah, I saw Ron was heading to Hawaii for business.
Oh, nice. Also, check out The Shot. Little shots
of astronomy science down your gullet.
So when's the next one come out?
We just had one come out on Wednesday.
What was the
and that is on SN 1987A.
Hey,
so
I know
check
who did that
it out. Another one will be dropping on
in 2 weeks.
But based on when you're listening to this, because this goes up on the pod on the Saturday after we record it, of course. So the 21st of February will be the next shot episode that we will need to record.
Oh, fun times. Okay, I guess we'll know what we're doing next weekend.
Yeah.
All right. So as always, have rules. If a puppy barks, we have them actually in the room now. So, they might take out, if it's not the internet,
whole set. If you just see the camera go flying, it's because the dogs.
It's because one of the dogs.
The dogs broke everything. They're in the room with us, hanging out. We were hoping to avoid Jack whining from the distance.
Yeah.
But
we brought Belle anyway.
I also expect Winter to just meander in here and jump up on me at some point. So.
Okay, but anyway, if they bark, we'll take a drink. If Winter comes in, you don't take a drink with that unless you want to. If there's any Star Wars or Lord of the Rings references, which there may or may not be, I doubt it. We haven't done them in a while. Then take a drink.
Maybe that should be the special drink. Like, how Brandon's been introducing, like, a special rule of the episode.
Yeah, we've only done it a couple times.
I know you're excited to get to Vera Rubin.
No, I had something in my eye.
So maybe the special rule of the episode is if the elusive Winter makes an appearance on camera, take a drink.
Not bad. Not bad. All right.
I'm glad you approve of your own drink, your own concoction.
Well, I did pour the tea on top, and all right. Anyway.
Also, when you drink it, I don't know if you put it out, but we got a little promo for Quark's Bar here, located in Oak Ridge, Oregon, or Deep Space Nine, whichever one you want to go to.
This one is more convenient, though.
Yeah, Ben, you have to know us personally to get in. So, just saying.
You have to know what?
Us personally to get in.
Yeah, that is very true. You can't just show up at the door.
It's a VIP special privilege bar.
It's like the old, speakeasy or
Yeah,
whatever?
that's our own speakeasy.
All right. Vera Cooper. Born July 23rd, 1928 in Philadelphia, Pennsylvania.
Oh, I think my grandpa on my mom's side was born in, when was Papa
Philly?
born? 1920, oh, maybe it was 1925. Anyway.
All the greats are born in July.
Yes, that's right.
Anyway, born July 23rd, 1928. Her father, Pasach Kobacheski, was born in Vilnius, Lithuania, which was then part of Portland, of Poland.
Did you say villainous?
Yeah, I don't know how else to say it. Vilnius?
Where are you reading?
Vilnius, Lithuania.
Oh, Vilnius.
Yeah.
I see, but I heard like villainous, like
that's probably
villainous.
That's probably how I did pronounce it.
1920.
But Vilnius, okay. Lithuania, which was then part of Poland. He immigrated to the U.S. and was an electrical engineer at Bell Telephone.
Oh, hey.
Yeah.
Cool.
He changed his name to Philip Cooper. Wanted to Anglicize it.
Oh, okay. Like the Giorgionis went to the Georges.
Like the Giorgionis. Wanted to make it sound a little bit more, English.
So he went from Pasach Kobshevsky to...
Cooper. Philip Cooper.
Philip Cooper?
Hey, go big or go home.
Oh, okay. All right.
He met, while at Bell Telephone, he met Rose Applebaum, who was also European.
Rose Applebaum. That just sounds like a 1920s, like, I don't know, like she was, I don't know. I'm just picturing like...
Anyway, she was from Moldova. And so Eastern European, and
so they have that in common. All right, they're bonding over their Eastern Europeanness.
I do not know what her. I don't know if it was Rose Applebaum, which doesn't sound like it probably was.
Rose Applebaum. If you want to make an American name,
that's it.
There you go.
So
Applebaum pie.
I don't have any name for her prior to that, but anyway. They met, they married, they had some kids, and Vera Cooper was one of those kids.
Oh, you know what? She must have snagged Paul, Peter, Mary Cooper. She must have snagged him with some Applebaum jeans.
Oh, God.
And her boots with the fur.
All right, anyway. In 1938, Vera is 10 years old. They moved to Washington, D.C., and that is where she developed an interest in astronomy.
Oh, in Washington, D.C.
Yeah,
okay.
So she developed that interest in astronomy while stargazing from her bedroom window. And so...
That'll do it. If you can see the stars, that'll do it.
And she says, quote, "Even then, I was more interested in the question than in the answer. I decided at an early age that we inhabit a very curious world." Aww. All from stargazing. Now, her dad did not want her to pursue a career in astronomy. However, though, he did foster that interest. He did foster that passion.
But he didn't want her to pursue a career because, woman and working.
Yeah, and he didn't think. No. It wasn't woman working, that kind of thing. He just think it wasn't going to work out for her.
Oh, okay. Because
not because of brains, just because of the way the world works.
Right, male-dominated field. She was just going to get kind of stomped all over.
Right, and so he fostered that passion in her, and they built a cardboard telescope together. And they used it to start observing and tracking meteors.
Wow, what a good dad.
Yeah.
That's cool.
So she graduated from Coolidge Senior High School in 1944, and it's off to college at that point. She was advised, and this is going to be a theme. Yeah, she was advised by a high school science teacher to avoid a career in science and become an artist. So let's see how that turned out for her. All right. So
Right.
she goes to college. Where does
You
she go
don't
to
want
college?
to do any science. Stick to some art. Be an artist. Ladies are good at the arts.
So as a side story, my daughter Stephanie was told by a boy that girls can't play baseball. I went and got her a baseball bat, a baseball glove, and we played baseball.
I mean, I would like to see this dude throw a softball.
Yeah, I know, right?
Freaking
Underhanded.
that.
Yeah.
Oh, God.
So Stephanie went on
To become a
to
famous
play,
baseball player in a league of their own.
She went on to play high school lacrosse, high school cross country, lettered in those, and this kid did nothing. Anyway.
This kid was a loser.
Back to Vera Rubin. So she decided she's going to go to college. She goes to Vassar College.
That's a women's college, right?
That at the time, that was a women's college. A women's college. She was inspired to go there because Maria Mitchell had been a professor there in the 1860s. Now, who is Maria Mitchell? Maria Mitchell discovered the comet C 1847 T1. It's now known as Miss Mitchell's comet.
Oh, that's fun.
Sounds very southern. Miss Mitchell's. It's all Miss Mitchell's comet. Anyway, she was the first internationally known woman to work as both a professional astronomer and a professor of astronomy at Vassar.
Wow, okay.
She was also the first woman elected fellow of the American Academy of Arts and Sciences and the American Association for the Advancement of Science. So,
good for her.
yes, and this is in the 1860s.
Yeah, that's
and so she was the reason why Vera Rubin goes to Vassar College. Vera Rubin graduated Phi Beta Kappa, which is an academic honor society. She graduated 1848 with a bachelor's in astronomy. She was the only astronomy graduate that year.
Wait, how many graduates were you in your physics program?
There were 2.
Yeah.
Yeah. Oh, me and Andre. I couldn't remember his
The
name.
one other guy you graduated with.
Yes. All right, let me take a drink here. All right, so she decides that she wants to now leave Vassar and pursue.
She has to. She graduated. She
Right.
can't stay.
Okay, she wants to leave and pursue graduate level studies. So
Right.
she sends out applications. She
Absolutely.
applies to Princeton. Denied. Vagina. Exactly. Princeton actually would not accept women for another 27 years. She turned down Harvard.
She turned down Harvard, the oldest college in the United States.
Yes. Now, there is a reason why she turned
Jeopardy.
down Harvard. She had met this dude in 1948, same year she graduated.
Okay.
His name is Robert Rubin. Last name sounds familiar, doesn't it?
Familiar.
Mm-hmm.
Looks like
He
she was
was-
getting a little R&R.
He was a graduate student at Cornell. They fell in love, they married, and she went to Cornell for graduate school.
Oh, yes.
So she received her master's in astronomy in 1951 from Cornell.
Oh, okay.
Yes, and then goes off to George Washington University to pursue her PhD, which she did get in 1954.
I wonder how much all of this was costing her. Like, maybe we'll say,
It was a scholarship to Vassar.
okay, so nothing to Vassar, and then $5 for each of the Ivy Leagues that she
Probably.
attended, probably.
All right, so now when you're in graduate school, this is when a lot of people do, some really fun research.
Well, yeah.
You're working towards your
Right, because in order to really get a career in like astronomy, you have to, do this.
and-
You have to get your do all these
and
research projects.
And for a PhD, you have to write a thesis. You have to defend it, and so it's a big deal. So she worked as a graduate student, whether it's for master's or PhD. So I'm lumping all of them in here. She worked with Martha Carpenter. She was an astronomer, and they worked on galactic dynamics.
Galactic. What's galactic dynamics? Like how they interact and their
movement dynamics is motion. So the motions of galaxies and so forth. She also studied under Philip Morrison, who was part of the Manhattan Project. He was also a high-energy astrophysicist. She worked under Hans Bethe, Nobel laureate, dude who figured out how stars make their energy.
I mean...
Studied under him. Studied under Richard Feynman, Nobel laureate. Also Manhattan Project, played bongos, loved strip clubs.
Well, you know, I mean, to each their own. He likes all kinds of bongos. Take a drink to that one, everyone.
Good.
Take a drink to that one, everyone. So she's got some bona fides on
she's
her
got some
resume,
real bona fides.
on
She's
her
got some real bona
reference
fides.
list.
But there's another one.
Oh,
George Gamow. He was a Soviet. Originally Soviet.
okay.
That's Russia for all
all of you Gen Zers watching us. I know we're just mid, right? I don't know what I just said.
But he then came over to America, so Soviet American, whatever you want to call it. But he just did all kinds of shit. He never won the Nobel Prize, I don't think, but he figured out this thing called alpha decay. So it's when a nucleus in an atom just spits out basically a helium nucleus, 2 protons, 2 neutrons, just spits it out.
Just willy nilly, just like
yeah,
like a a cowboy in an old western, just
yeah,
with the
pretty
tobacco.
much just spits it out. So he figured that out. He figured out this. He was one of the first people to figure out this. It's called a liquid drop model of the nucleus of an atom, which Niels Bohr then signed on to and was involved with it as well.
Next time, every time now, going forward, that I need to use the restroom.
Liquid drop?
Excuse me, I gotta go liquid drop.
Well, that could be anybody, really. It's not just you.
Oh, God, I laughed so hard, I liquid dropped. Hey! Brandon has just joined us in chat from his adventures in South America.
Yep. And
Hola!
He also did a lot with how elements are fused in stars. So he also was very instrumental in the hot Big Bang. He's a big proponent of it. Also figuring out when, like,
there a
in
cold
the
Big
first.
Bang?
Well, at the time, they weren't entirely sure.
Okay.
So he was figuring out, like, he was very instrumental in figuring out, like, how much hydrogen and helium were made, how much lithium, all of that kind of stuff. And so, big deal.
Yeah.
This guy's a big deal. And so, he is her, Vera Rubin's PhD advisor. So she worked under some big time people.
Yeah, she did. Jeez.
So while she was in graduate school, she observed the motion of 109 galaxies and was one of the first to observe deviations from the Hubble flow, which is as the universe expands. Okay, all right. So as the universe expands, it takes the galaxies with it, and they should all be kind of going at the same speed. However, if you look at some are going a little slower and maybe heading in a different direction. So deviations.
Okay.
She's one of the first to figure that out.
Flow.
She did think, her and some colleagues did think that galaxies moved around the pole, which has been disproven.
A pole.
Yeah,
like
so they're
pole?
orbiting. So, like, the universe has a pole.
Oh, the universe has a pole. Okay.
And so that has been disproven.
Yeah.
She also proved early evidence, or provided early evidence for the supergalactic plane, which was controversial at the time. Basically, it is the plane of the Milky Way galaxy.
Yeah.
We can't really see it.
No, because we're in it.
Because we're in it, and the dust lanes block our view. But you can infer there are a lot of galaxies there.
Well, I mean, just look at the Sombrero Galaxy.
Right, and so she's able to provide evidence for galaxies in the supergalactic plane. Her paper was summarily rejected.
Vagina?
No, it was actually a very controversial idea at the time. So this was legit, but this next part though is vagina.
What was the leading hypothesis at the time, that galaxies were like spherical. I mean, some are, of course.
Right, right.
But...
So I'm not really sure what the idea was at the time. She has been since proven correct. But we can't just see there, but there's evidence that there are these galactic clusters, and she was saying that there's these galactic clusters there, and people just weren't buying it.
I feel like I don't know. It's like that shouldn't, like, nothing. Anyway, no. Go ahead, continue.
Anyway, the paper, because it was a controversial idea, was rejected, and so rejected.
But it should be rejected on merit, and not that it's controversial. Like, is there does she have shit in it that is, like,
no, I agree.
verifiable or, like, good evidence to
I agree.
I know, you agree.
I agree.
I know.
She also wanted to present her findings at the American Astronomical Society. She had to fight to be able to do it. Not, like, physically fight, but she had to really... Wait a minute. She had to really fight to do it because... she was visibly pregnant.
God.
But she did end up being able to present. She also, as a PhD student, found the galaxies clumped together. It was controversial at the time. And it's true that they do clump together. It was not pursued by other astronomers for another 20 years.
We know, like, nothing, yet why are there things controversial? Okay, today, obviously, we know a lot more because we have the technology to observe a lot more, and obviously we know the Earth is round, so hence why no controversy over flat Earth, because it's just wrong. But, I would say pre-space telescopes, let's put the word controversy to bed, because we still don't know shit.
Yeah, well, but people still go into things with... we held on... Yeah, preconceived ideas, and
right.
We held on to Aristotle's beliefs of things. For centuries and centuries.
A dude that didn't have indoor plumbing.
Right, but we held on to those beliefs. Yeah. It took...
hubris does.
It took, Newton to come in and change things. And then we held on to that. Mm-hmm. And it took Einstein to come in. It took, Niels Bohr to come in. Mm-hmm. We hold on. Like,
we
once
don't
you
like
get...
change as a species.
We don't. And also, the people that are in charge, mm-hmm.
Mm-hmm.
They get married to their ideas, and after the age of 30, they really are holding on to those ideas, quite passionately at times. Anyway, she dealt with a lot of sexism, obviously, in the field and at the university.
Oh. What?
Remember, she is a PhD candidate. She has an advisor.
Uh-huh.
She wasn't allowed to meet with her advisor because women weren't allowed in that part of the Catholic university. So she had to meet with them elsewhere.
What? Because the temptation's too great? Because of all these
it's the
zipped up
women,
Catholic guys?
It's women that tempt the men, right? And it's not the man's fault. It's the woman's fault, isn't it?
Shouldn't it be apples? Should it just apples? Just everybody should be tempted by apples all the time?
Yeah, you would think.
I guess. Never mind.
Anyway, she did get that degree in 1954, and she is now Dr. Vera Rubin.
Dr. Vera Rubin. Look at that.
So she does with that PhD in hand. She goes down to Montgomery College, where she is an instructor of math and physics. She's there for a year, and then she goes back to George Washington University, where she starts off as a research associate astronomer. So mm-hmm. she's doing research. Then she becomes a lecturer from 1959 to 1962, and then advances to assistant professorship from 1962 to 1965.
All right.
And then she leaves George Washington University, and she goes to Carnegie Institute of Science, and which at the time was Carnegie Institute of Washington, and that's where she stays. And she is in what is the department she is called the Department of Terrestrial Magnetism, which I just think is a funny name.
The Department of Terrestrial Magnet. That sounds like you've got some great terrestrial magnetism.
I know,
I'm really
right?
attracted to his terrestrial magnetism.
All right.
Department of Terrestrial, but that seems like it's just like what the Earth's magnetic field is what that would be about.
Yeah, but they study a lot more.
Okay, in the Department of Terrestrial Magnetism.
So there she meets her longtime collaborator, Kent Ford. So, yeah. But anyway.
Kent Ford, okay.
Kent Ford.
I mean, I don't know who that is, so.
Yeah, well, longtime collaborator.
Male,
I don't know him
female.
either. Kent's guy.
Oh, Kent. I thought you said Kit. Like Kit.
No, Kent.
Okay, Kit, because that could go either way. But Kent. Okay, Kent.
No, Kent.
Kent.
Yeah.
Oh, Brandon said it's a subdivision of MIB, Department of Terrestrial Magnetism.
All right, yep. Okay. And so Kent Ford is really a master at creating spectrographic equipment and stuff like that. And so he creates some equipment that they use to get spectrum of galaxies.
Yeah. If you don't have what you need, make it yourself. Jack says, new country song, I'm attracted to your mountain.
Because Vera Rubin and her husband had produced at that time 2 small children.
They produced them?
They produced them.
Out of her Hubble flow.
God. She worked mainly from home.
Oh, so, that's nice that she had to work from home abilities back then.
Yeah.
All right.
In 1963, so prior to going to... All right, so I'm going back in time a little bit. A couple of years. 1963, she goes to McDonald Observatory. She worked with Jeffrey and Margaret Burbidge and made her first observations of the rotations of galaxies, which are going to come back to us in another decade.
How long did it take to make a confirmed observation of? I guess it's a redshift, blue shift deal. Then, yeah, just because I mean, I would feel like the rotating is slow.
Well, you got to be able to see what you have to. Yeah, but what you need to be able to see are the stars.
Oh, and there's shift, and then you measure the amount of shift, and you can then extrapolate the speed at which then they're rotating. The galaxies rotating because they're just like the planets in the solar system.
So they're measuring how fast things are moving, and so you got to be able to see the stuff in it to be able to get those measurements, and so I don't know if they're actually picking out individual stars at this point, or if it's just like, hey, this side is moving this fast, and this side just on average is moving that fast. But that's where she's making her first observations of it. 1965, she goes to Palomar Observatory. No women's bathroom. So what does she do? She makes her own.
Oh, did she just like get a bucket?
I guess. She was the first woman.
Find a closet? Slap a sign on the door? Okay.
She was the first woman to observe there. And made history. Goes back to Carnegie. And she's working with Ford, and they find what is called the Rubin-Ford effect, so they're working together and they're looking at the clumping of galaxies, which, remember, she has kind of already seen and had ideas about with her graduate work. And they're looking at how these galaxies are moving. They discover an apparent non-uniformity in the expansion of the universe on the scale of about 100 million light years. So you're looking at the galaxies.
Okay. You're looking at a group, like an
right,
area,
and they should be moving at a certain speed. So what they did was they compared, like how fast the Milky Way and our galaxies are moving, and then they look at some galaxies a little bit further out and see how fast they're moving, and then you go even further out and see how fast they're moving. Okay. They should be following Hubble's law. She's finding they're not. This is before dark energy. We knew about dark energy, but
not. The galaxies are misbehaving.
They are misbehaving. It was controversial at the time.
Of course, everything's controversial.
But it was shown to be valid. And so basically they're studying the motions of galaxies.
Okay.
So, wishing to have a non-controversial topic of study.
I mean, then you just gotta do one that's already done. If you want to be a trailblazer, you gotta be controversial sometimes.
Well, I mean, pretty much everything she touches has been controversial so far. But wait, so wishing to have a non-controversial topic of study,
like normal.
Rubin chooses to study the rotations of galaxies.
But isn't that already controversial?
No, it's the motions of galaxies that are a little bit controversial. It's the rotations of them,
that are supposed to be like,
you know what? The reason why the reason why they were thinking it wasn't controversial was they thought that that galaxies really are just much larger versions of solar systems.
Oh, okay. So
stars at the center, stars near the center of the galaxy are going to move. They're feeling more gravity. They're going to move faster.
Mm-hmm. Or they're gonna
and as you get further out, things start to slow down. Like in our solar system, Mercury goes the fastest of all the planets.
Wasn't it not about speed though? It's about like less time it takes to orbit the sun, and then it takes more time.
But you're feeling more gravity,
mm-hmm.
and so you have to go faster.
Mm-hmm.
Otherwise, you fall in.
Oh.
So
okay. Yeah.
So it's not so much the shortness of it.
Uh-huh.
So if you don't even worry about how far away they are, if you just look at their velocity
mm-hmm.
That they are going, Mercury is going much faster than Neptune. It has to. It's feeling more gravity.
Okay, yeah,
It has to go faster.
Yeah, okay. Because if it went the same speed as Neptune, it would just go poof.
Right.
And then no Mercury would not last.
Mercury would not be here. So she thinks that is the prevailing theory, the prevailing thought.
And then controversy comes over and goes, hey!
Yeah. You can't escape it, Vera. So what she does is they start to measure the speeds of stars around the center
mm-hmm.
of the galaxy.
Okay.
And she found that stars were moving at the same speed in the outer reaches of the galaxy as they were close to the center of the galaxy, which should not be happening. These outer stars should be going slower.
And if they're going real fast, then
that means there's more gravity.
If they're going fast and they're thinking that it's the whatever same gravity, then they should like fly off, right? But they're not flying out.
Right.
They're staying in.
Exactly. So she measures their velocity.
Brandon says my straw is ridiculously long, hilariously long. Well,
okay.
I need a straw.
I have a lot of stuff, guys.
Okay, but you know what? We gotta have fun. We gotta banter.
Anyway,
they'll sit through it.
Oh my God! Leia, come finish the show. Leia, come finish it. Anyway, the stars. Yes, you're right. They should fly out of the galaxy based on the amount of mass that we're seeing, that we can see. These stars are moving too quickly. So,
mm-hmm.
for them to be able to stay in orbit around the center of the galaxy, there has to be a bunch of unseen, invisible matter that they can't see that is, there and present and keeping these stars in orbit.
Mm-hmm.
Otherwise, the galaxy would just dissolve. It would fly apart at the seams.
Can we just all take a second to just visualize a galaxy just like flying apart?
It'd be a lot of fun.
I mean, how cool would that look, though? All of a sudden, it was just like, just not even an explosion. It was just like, that would be cool.
So she postulated that there had to be this halo of matter that we can't see. And dark matter halo. She did not coin the term. That actually was coined by
Rihanna.
No, it was coined by Fritz Zwicky in the 1930s.
Hey, good old Zwickster.
Zwicky had been looking at the Coma cluster of galaxies, and he found that galaxies are moving faster than they should. It would break apart. So there had to have been some sort of invisible.
It was a cosmic glue.
Yeah, there had to be some invisible matter that he called dark matter but it was like in French or something, and so it actually sounded a little bit cooler. But she finds her data supports ideas first proposed by CwC in the 1930s. And CwC kind of laughed at about this dark matter stuff. And, here 40 years later, Vera Rubin comes in and says, you know what, maybe he was right. And so dark matter has been confirmed by radio astronomers, cosmic background radiation, gravitational lensing. Everywhere we look, now we can see evidence of dark matter. But
not
Rubin,
the actual dark matter
itself.
We don't know what the fuck it is.
We don't know what that is. But Vera Rubin CwC was the first to see it, but he only saw it in the Coma cluster of galaxies. Vera Rubin saw it in all the galaxies.
So every galaxy she studied, she noticed, hey, these stars further out from the core are going way faster than they should be.
Yep.
So there is something holding them all together, which means that the Zwickster back there, when he said this about it tracks. So there's something here. There's something here, guys. There's a glue here.
Right, but it's not just in this one cluster. It is universal.
Yes.
It's everywhere.
Yes.
And so she calculated that there had to be 5 to 10 times the amount of dark matter to visible matter, which is roughly true. It's 10 times.
It's 10 times?
Yeah, it's roughly 10 times.
That's a lot. That's a lot of excess.
Yep. So,
matter.
Quote, in a spiral galaxy, the ratio of dark to light matter is about a factor of 10. That's probably a good number for the ratio of our ignorance to knowledge. We're out of kindergarten, but only in about 3rd grade. Vera Rubin.
Yes, and we're still
there.
We're still there. We're just keep getting held back a little bit. Or we're slowly going, maybe we're in 4th grade now. I don't know.
Yeah. And so wanting to avoid controversy, she doesn't avoid it. But this actually does end better for her because...
Well, I mean, she confirmed something else that was already
definitely
said.
More...
she's not the first saying it.
Right.
Or, you know...
Also, something that she was interested in, Rubin was also interested in counter-rotation in galaxies. So, while she's studying stars, she's noticing, she's getting their velocity and all that kind of stuff. But she is noticing a few things that are going the wrong way.
Ooh, just like in our solar system, we got shit going the wrong way.
Yeah,
is it a similar...
Yeah, because at the time, they thought everything... went in the same direction.
Yes.
And so she's the first one to find, no, there's actually some stuff going in the opposite direction. And this is the first evidence of galactic mergers.
Oh, so that's what's caused it, is that just like, okay. So like, for example... Uranus rotates backwards, contrary to the rotation of the solar system, which is counterclockwise. So it rotates clockwise. And it's also tipped over on its side. But so that means it was hit by something.
Oh, yeah, to tip it over.
To tip it over and cause it to rotate backwards. Does it rotate backwards or just
tip over?
Which one rotates backwards?
Okay, hold on.
Venus?
All right. Venus is upside down, so it appears to rotate backwards. But everybody goes in the same direction counterclockwise around the sun.
Okay, yes, but yes, they all go around orbit, but yeah, I'm just making a comparison that some rotate the opposite way, meaning that they had to have been smacked to get that contrary rotation. And so I guess that makes sense with a galaxy, that if they're merging together, then your initial rotation for that galaxy gets messed up from that merger, and so it can cause stuff to...
So you do have a spiral galaxy that's rotating counterclockwise, and then you have another galaxy come in. It's probably a lot smaller. It definitely is a lot smaller because the spiral galaxy is maintaining its shape. And so the smaller galaxy comes in and collides with this galaxy, but it's going in such a direction that it goes around the galaxy clockwise.
And then so some stars then
stars are going with it. Yep.
Yeah. Okay.
Yeah. All right. So we have this dark matter shit, and we need to try to figure out what it is. And so in the 70s and 80s, there was this, and actually 90s, there was this thing called MOND. It means Modified Newtonian Dynamics. And
So of course it was an acronym or initialism.
So if you look at Newton's theory of gravity, it's basically 1 over r squared, right? And so...
Yeah. What goes up comes down.
Right. Okay, so the equation for it, you have some shit with gravitational constant. It's a really small number. Right. And then you have this product of the masses of the two things. But then you divide that by the distance between them, and you square it. And so basically... So
you add a tiny 2.
Above it, yes. And so, you square the distance between them, between the two objects. And so that means that if you have one ball at position 0 and one ball at position 2, they feel a certain gravity towards each other. But if you double that distance between them, that the gravity they feel is now 1/4.
It's less.
1 over 2 squared is 1 over, it ends up being 1/4. And so the idea at the time was, you know what, maybe that 2 isn't really a 2, maybe it's a 2.001, maybe 1.97.
The 2 is a lie.
Yeah. And so it was considered,
controversial?
No, but I mean, yeah. So
word of the episode, everybody. Controversial.
Do we need? That should have been the name of the drink. The controversial. Anyway, the question was, do we need to now take a closer look at Newtonian physics and take a deeper dive into it? Maybe modify it.
Yeah.
And the answer is no. Oh. We don't need to do that.
No, but it could be fun just to do it anyway.
Yeah. Rubin did have a thought on the matter.
He's not going to care.
Not now. Rubin did have a thought on the matter. She said, if I could have my pick, I would like to learn gravitational interactions. Oh, wait a minute. I would like to learn that Newton's laws must be modified in order to correctly describe gravitational interactions at large distances. So she would like for MOND to be true.
Oh, okay.
That's more appealing than a universe filled with a new kind of sub-nuclear particle.
Oh, so but how do you feel about that? Okay, now this is tough because you love your Rubin, but oh my God, new particle physics? Wow, you would rather have that, a universe filled with a new particle.
Yeah.
Oh man, it's controversial.
No.
Your feelings, I think, are.
I still love you, Vera.
My mom says she's still wondering how we know Venus is upside down.
It's rotating backwards, and it's the only explanation. So all right. So as the solar system is forming, it starts to spin. It starts to spin counterclockwise. And the rotations of the planets also get part of that spin. So they are rotating counterclockwise. All that debris
is going in the same direction as it's coming together through gravity.
It's called conservation of angular momentum. Everything is going to be moving in the same direction. And so when you see something like Venus, which is going around the sun in a counterclockwise direction, the correct direction, we know that it picked up that spin of the early gas cloud that formed the solar system.
Solar nebula.
But when you look at its rotation direction,
it's going the wrong way.
It's going the wrong way.
So some of them have smacked it.
And so it is impossible for Venus to be going around the sun counterclockwise
and rotating clockwise.
And then form rotating clockwise. It can't happen. And so physically it can't happen. No. And so what happened was, we're really sure that this is what happened. because we weren't really there. It formed going around the sun counterclockwise. It also was rotating on its axis counterclockwise. And then something came and smacked it. Now, in physics, it doesn't have to be a direct smack, like it actually hit it. It can also be what we call a gravitational collision.
A close flyby.
A close flyby, which then flips it. And now it's upside down.
Hey.
And
Venus is like, what the fuck?
So it could have been hit. That's a bad day for anything that would have been living there if there was, which there wasn't. But, you know, you could have also had something very close to it, just come very close to it and just flip it over. Also, a bad day.
I wonder, side note, just a question not to go into, but like, would that have helped? I don't know, just increase its internal friction for all that volcanic activity and stuff.
Yeah, I mean,
because of that.
You have all these tidal forces going on.
Yeah.
When something that's just a close one, so all you gotta do is look at Io.
Oh yeah.
So I mean, it's
got
really
Jupiter
going
and all the moons just making it go. I was like its own little rave.
Yeah. What is it like? The Io surface goes up and down something like 60 feet every day.
Yeah, it's like
because of the tidal forces.
Jack on chat says, ancient sexist astronomer view. Being a woman, Venus struggles orbiting the sun because of her gentle constitution. Yes. Exactly. That's exactly what it is. She's just so fragile for the sun.
So, I mean, let's just think about this for a second. She's one of the first to notice that not all the galaxies are following the Hubble flow.
Yeah, how many women in astronomy are the ones that are like, she's the first to notice something that all the men are not observing?
Okay.
Typical.
She is the first to really figure out, at least universally, that dark matter exists.
When did they first coin the term dark matter? Was it?
It was in the 1930s. CwC did it.
Oh, CwC coined dark matter. Okay.
And it's something French. It was something
right.
French.
That's right. Okay, I got here. I'll Google the dark matter French term because I'm curious now on what it is.
Yeah. Or it looked French to me. Yeah. Anyway, and she's also the first to.
Matière obscure.
Yeah.
Obscure matter.
Yeah.
Obscure.
Well, but that means dark.
Oh, okay.
So.
Matière obscure.
And she's also the first to make observations for galactic mergers. I mean, these are some big things. So, what is her legacy? Her legacy is she's the second woman elected to the National Academy of Science. Margaret Burbage, who she worked with previously on galactic dynamics, was the first. She has been described as a guiding light for women that want a family and career in astronomy.
Oh my God, that's controversial.
Yes, Carnegie Institute has a postdoctoral research fund in her honor.
Oh, that's cool.
The American Astronomical Society has the Vera Rubin Early Career Prize. Yeah. Asteroid 5726, Rubin, is named for her. She also has the Vera Rubin Ridge on Mars. So that's cool.
Nice, that's neat.
On November 6, 2020, NewSat 18, a satellite meant for actually observing Earth, I believe, was launched. It is called Vera in her honor.
Oh.
She will be honored on the U.S. quarter in 2025. I want one.
Oh, okay.
And it will be on one of our, yes.
Real physical money.
Yes. And, like, I think it is...
Sorry.
Oh, shoot. So, you know, New Zealand, oh, God, his name... I can't remember his name, but they have a physicist that won a Nobel Prize on their money. Other countries.
Canada has like
space arm. They have a space arm.
Yeah, they got cool shit on their money. What do we have? We have a pyramid with an eyeball. What the fuck is that shit?
But we also have dead racists.
Well, yeah, we got our dead racist, presidents. But a pyramid with an eyeball. What?
In December of 2019, the Large Synoptic Survey Telescope was renamed the Vera Rubin Observatory. It is located in El Peñón in Chile, and it will focus on the study of dark matter and energy.
Hey!
In Season 3 of Star Trek Discovery, the Verubian Nebula, named after her.
Oh, shit!
I know, right? Yep. Vera Rubin. Verubian.
That's cool.
Named
That's
after
cool.
her.
No, hats off. Oh, damn it. This has been the story of my weekend, is spilling constantly on myself. You don't understand how many times I've spilled on myself just yesterday.
We had to wash clothes.
I had to wash clothes because I spilled a dark beer on myself. What was I going to say? Oh, yeah. Hats off to the writers on Star Trek Discovery for that gold nugget.
Yep.
That little nice Easter egg to...
She has won many awards. I will get into one she didn't win. But
I know. I'm just waiting for
I'm
the rant.
I'm really trying to not rant. I'm really trying not to. But anyway, she has won the Bruce Medal, the Gold Medal of the Royal Astronomical Society, the National Medal of Science, the Adler Planetarium Lifetime Achievement Award.
What?
She has also received honorary doctorate degrees from Harvard, Yale, Grinnell College, and Princeton.
Oh, those assholes.
Right?
Those dicks. Was she alive for all these?
Yeah.
Because
that
you
Princeton go
one,
give the talk.
do you accept the Princeton one, or do you be like, no, fuck you? I'd be so petty. I'd be like, you could take your award and you could shove it up your sexist asses.
But you know what? I really want to look up now her Princeton... because you have to give the speech.
Oh, her speech.
Yeah, I want to look up her speech.
If she threw like some sly shade in there.
She had to.
I'm sure she was a classy lady, but...
She died on December 25th of 2016.
She's Jesus.
Well,
that's the birth, yeah.
From complications of dementia and became ineligible for the Nobel Prize despite, quote, and this is from the New York Times, ushering in a Copernican scale change in cosmological theory. All right, so one final quote. She did like to not be front and center in a lot of things.
Okay,
and
she didn't like the center of attention. She liked to be in the background, operate in the shadows.
But anyway, one final quote. We have peered into a new world and have seen that it is more mysterious and more complex than we have imagined. Still, more mysteries in the universe remain hidden. Their discoveries awaits the adventurous scientists of the future. I like it this way.
Yeah, she likes, that not everything is known, of course.
Yeah, and, she was such an inspiration and influence to a lot of, female. She paved the way for a lot of female astronomers today. There has been a lot of anger towards the Nobel Committee because they never...
Yeah, how many women have won a Nobel Prize?
Right.
In science.
But, how many women have never won a Nobel Prize that deserved a Nobel Prize? Right. And, I argue Vera Rubin is one of them, and I'm not the only one.
There should be a posthumous Nobel Prize.
There should be.
They don't need to award the money out or anything. Right. Just a posthumous, this person deserves it.
Right. And
just because they're dead doesn't mean that they shouldn't be honored in some way. We honor the dead all the time.
Yeah, and there is... there are so many women astronomers who, thank her for it, and they have told the Nobel Prize committee that, they are where they are because of Vera Rubin, and the path that she She blazed, and she gracious the whole way through. She never said anything bad about the Nobel Prize. She basically would, when they would, when somebody would ask her about it, she would do the whole Newton thing. I stand on the shoulders of giants.
Oh yes,
yes.
Yes.
So
classic.
And it's very gracious, but the Nobel Prize really fucked it up.
You fucked it up.
They did.
You fucked it up. No, I'm talking to you. You Nobel Prize committee people.
But she fundamentally, with looking at galaxies, and how stars move in them, completely changed our understanding of what the universe is made up of.
Yeah, because it's made up of, basically, it's made up of, like 99% of shit.
Yes, 95%.
I'm combining the dark energy and dark matter. It's basically everything, the majority of the universe is made up of shit that we can't see and don't know what the fuck it is.
So, but at the time, it was, after her discovery, this is pre-dark energy, so this is pre-1998. 85% of the universe we did not understand. If you're looking at matter and stuff. It's something. Wait a minute.
I feel like.
No, I think it's like 85%. No, it's 5 times. No, 10 times. Yeah, so you're talking about 10% is visible if you're just considering dark matter, and 80%, 90% is invisible. We don't know what it is, and so. So anywhere, we'll say 25-75. 25% of the universe is made up of normal matter that makes up trees and stars and planets and you and me and microphones and electrons that allow us to do this weird thing every 2 weeks. But
and Jackie.
Yeah, but 75 to 85% of the matter, we don't see it.
Yeah.
We know that it's there because we see its gravitational influence on things. We don't know what the fuck it is.
I would even say that I would say that even with the stuff we can see, we don't understand 95% of the universe and how it works. Just because I feel like we have a long way to go.
We do. And Vera Rubin finds this invisible nature of the universe. She finds that not everything is moving like we think it is. You have the expansion of the universe, and you're thinking that all the galaxies are going to have the Hubble flow. They're all going to expand at a certain rate, and she finds that's not true.
Sometimes that Hubble flow is just unpredictable.
That there are deviations from it. She has looked at these galaxies and found, hey, galaxies run into each other. And
we got 2 running into us right now.
Yeah, and so they merge, and here is the evidence for this. These were paradigm shifts in our thinking at the time about galaxies and about just a large scale of the universe. She was instrumental in the idea of galaxies clumping together. And when we look at big data sets of galaxies, what do we see? We see them clumping together.
Well, I mean, but that seems like not controversial, because
it's not controversial now.
All that gravity, you would think that they would naturally be drawn together.
But the idea also is that the expansion of the universe's point is taking them out.
Right. Oh, right. I forgot about the expansion of the universe.
But there's this whole other thing about dark matter. If you want to see where the dark matter is in the universe, take a look at the spider web pictures of galaxies, where
the cosmic web.
All of these filaments and strands, those are where the galaxies are lining up. Where are they lining up? They're lining up where the dark matter is. And Vera Rubin found that dark matter. She found it. Fritz's Wiki laughed about because of some of his ideas. Rightly so for some of them.
He was also an asshole, but
he was also an asshole.
You get more, bees with honey.
Yeah,
or
true.
Flies with honey.
That's true. Yeah. But she proved it. And like overnight, the universe went from, hey, everything is made out of protons, neutrons, and electrons, or quarks and leptons, basically. And she was like, no, it's not. Her discovery is so profound that with dark matter is so profound that it's one of two things. It is you fundamentally have new particles in physics. Dark matter particles,
yeah, you're excited about that one.
Or you have to rewrite Newton's laws.
Oh, we don't want to do that.
No, but that is equally exciting.
As if to you, which one's more exciting?
The particles.
Well, yeah,
but that's
shit.
because that is because I love high energy physics, and that's all about particles. But either one is you are rewriting physics books. From this one discovery, from stars not going at the speeds that they should go.
That they were assumed to go. And you know what? That makes an ass out of you and me when we assume the nature of the universe.
That's so true. So true. And so, and she had to deal with sexism her entire life, to the point where she makes her own bathrooms.
Yeah.
And she overcame all of that. Graciously overcame all of it.
I feel like the majority of women do overcome it, and they have to do it graciously, otherwise they're labeled dirty words.
Yeah, and so she did it with her head held high. And she should have gotten the Nobel Prize. She should have gotten the Nobel Prize long before she got dementia and would not have even known what the Nobel Prize, because at the end,
Oh, right.
And Nobel Prize, you guys fucked up. You fucked up.
You heard it here, not first.
From somebody who will never get a Nobel Prize as well. So, it's I was introduced to Vera Rubin from PBS, the astronomers.
Oh.
And I was like, holy shit.
It's revolutionary. It's revolutionary work.
Yeah, and the awards that I presented, that's just a small list.
Of her awards.
I included the Adler because of the Planetarium connection, but I thought that was kind of cool. And she rewrote
the universe.
I was gonna say astronomy textbooks, but I like that. And she rewrote the universe. Yes, she rewrote the universe, and at least for 20 years until dark energy came around and really rewrote the universe.
Dark energy's like. Hold my beer.
Hold my beer.
Wait, you think dark matter's crazy? Wait a minute.
All right.
I got an adventure for you.
All right, so I think what we do is we call it.
We'll go to The Hangover, where Mike can further rant about...
Well, I don't know. All right, anyway. Join us in a couple weeks. Thanks for joining us today. And where we talked about Vera Rubin, one of my astronomer heroes. And love Vera Rubin. And we're going to name our first kid Vera. With boy or girl, doesn't matter.
Okay. That's not a bad name. I don't object to it.
No. Anyway, stick around.
Vera Picard.
Hey. And join us for The Hangover. And if you can't do that, then join us in a couple weeks, where it'll be a high in the sky for
March, because the time keeps on ticking and the seasons keep on moving.
God, it just really
Earth keeps on rotating and orbiting.
I think that's going too quick. Anyway, thanks for joining us. We'll see you in a couple weeks. Cheers, everybody.
If you're with us now, stick around. We'll be back with The Hangover. I don't know what that voice was. Cosmos with Cosmos!
Well, Brandon's already looked up the year that Vera Rubin got the honorary doctorate. Chevy Chase gave the keynote. Yo-Yo Ma received an honorary doctorate. And Toni Morrison got an award. Toni Morrison, great books. I like Beloved. Beloved.
I don't read.
Yes, you do. Oh my God, you're reading now.
I am, actually. I am. I'll start the hangover off with just a little plug. I am reading. Oh, you know what? Can you get up? Can you go get the book is in my backpack. It's right over there.
That means I got...
You have more room. I'm blocked in. I'm blocked in.
You
I
made
got,
that
look,
choice.
I got controls. I got drinks. I'm blocked in. But...
That is a choice. You didn't read this last night. What were you doing? You were just looking at
I've been going down a rabbit hole of clothes to wear at a wedding in July. But I got a book. We were in Portland visiting Katie, and we went to Powell's, and I got this book, A City on Mars, by Kelly and Zach Weinersmith. And Zach Weinersmith, he does the comic. Which comic is it? I can't remember, but it's really funny. Breakfast cereal, Saturday morning breakfast cereal, and it's all about like space settlement, which now I'm like, this would be a very interesting topic, because I remember in the planetarium, I talk about, I mean, and in sci-fi, we always think about, terraforming and colony, we got to build the habitat and all that. But there's a lot of things that I didn't think about that goes into space settlement. And this is written in a very witty, cheeky, funny, and realistic point of view of how we are nowhere close to being able to do space settlement. I recommend it. It's really fun. And it's got, some plugs, it's got, some, nice reviews from like Andy Weir and Phil Plait, and stuff. So definitely a good read. It's rare for me to give a book review. Usually it's Brandon's book, Brandon does his segment on a little book review or whatever. But so that is what I'm reading, although next on my docket of reading, because my goal has been to read more while going to bed instead of browsing through just the endless like shit cycle that is like what's happening in the news or whatever. And so the next book I'm going to read, which I've read before, and it's called Endurance, and it's about the Shackleton voyage to Antarctica, and it's a very good read. It's very enthralling.
Does it make it?
Not spoilers, I'm not going to tell you. It happens, but it gets very dicey. Yeah. It gets very dicey. But anyway. Brandon says, fun fact, Kelly Weinersmith gave me their first book in D.C. That's cool. And Brandon also says Endurance is a great read. I guess was it Soonish? Because they are the best-selling authors of Soonish. I don't know if that was their first book, but...
Can I have your straw? For a second?
Oh, you just want to stir.
Yeah. Okay. Jeez. Don't look at me like I'm crazy.
Well, you never use a straw, so it's an unusual...
Well, Federico has joined us.
Oh, no!
I think he's just getting over the rugby match today.
Uh-oh, Federico... Never mind.
Federico, I was hoping Italy was going to win.
My mom just texted me, and she said she loves our shelves and all the stuff on them.
Oh.
So thank you. We've added some decor. We did yesterday try to apply peel and stick constellation wallpaper. But unfortunately our walls are slightly textured, and so the air bubbles would not come out, and it was not going great.
So we turned it down. But there was a certain satisfaction of pulling it down.
Yeah,
too.
When we pulled it was actually very satisfying. So we were like, you know what, we'll put up some shelves in the meantime. We'll eventually paint the wall and whatever, but we figured we put up some shelves, and we finally got to display these cool little Lego space scenery things that Mike got for Christmas that he put together.
Yeah. Yeah, so... Vera Rubin.
Yes, the main show was about Vera Rubin before we started talking about book recommendations and miscellany.
Oh my gosh. Yeah, Vera Rubin. I don't know. They say never meet your heroes. but I think I would have loved to have met her. I think
When you were researching the episode, because Mike did most of the I'm here for just I'm here for the wit, and to annoy Mike as he tries to read through his notes.
Well, you did do that.
Yeah, I know. You gotta let me have my one thing that I'm not that good at.
You have your one thing a lot.
Yeah, well, that's what I'm here for. You gotta make it
you gotta let me have my thing too.
You have a lot of your thing. But while he was doing the research for it, while you were doing the research for it, I'm posing you a question. That's right. Look, you made the drinks, so you can't blame me for what's happening
question.
Right now.
Focus.
Query. Was there any indication of like her personality, like as a person, like how she was in person on things? Like, was she serious? Was she kind of more fun? Was she she was just like a nice lady?
I didn't get that that feel from it. Sometimes like you'll read like
I'm out here being controversial.
Like George Gamow, they'll say notorious prankster. He was. George Gamow wrote this.
Just like George Clooney.
Yeah, exactly.
It's a George thing.
It's a George's.
Ha!
I don't think I'm a prankster.
Well, I mean, you like to at least sneak up on people.
I do not. I just walk in. Not my fault you can't hear it. But anyway, so I wasn't getting that feeling from her. But the main thing that I was reading was how much of an influence she was on people, and so
clearly not. She didn't. At least she didn't earn a negative reputation, like Zwicky being like an asshole to people, or
no, not at all. Not at all.
Bore like in the strip clubs. Feynman like in the strip clubs. Who else was it? Goddard? Was it Goddard who was in the whole like swinger movement thing, or who was
Schrodinger was? Schrodinger was swinging. Yeah. So I mean, I'm sure that Rubin had their thing. Everybody's got their thing, but oh
yeah, my mom asked, did her kids what happened to her kids? What did her kids do?
Oh, there was nothing about the kids.
Oh, they didn't do anything. They were just like
I hate our internet.
We lost there we go. We lost internet. Jack is the new host in the meantime. Yeah, okay. Mom, whenever you see us frozen on the TV I don't know. I'm looking at the stream to see if it'll come back. Oh, I need to I don't know if I can reconnect. It's not giving me an option to connect, but it says excellent connection. So I don't know if it'll come on.
Oh my god, that is. God, I want that quarter.
Come on. Like we're streaming, it's on. We're getting actually a good refresh and see what that does.
Oh shit.
Hey, wait. Oh, okay. I think we're back.
Yeah, leave my phone as is.
You know what? Okay, we'll leave it as is for right now, but just leave yours as is right now, even though I do have Wi-Fi. But we're using Mike's hotspot. His phone.
Which is really weird. Okay, we are back.
Yeah.
Do we need to do anything with the chat?
Yeah, the chat is not, I don't know why the chat on our screen is not connected, but...
Do we know who won the Super Bowl?
Live chat. Okay, there we go. Well, it's only 2:30. Have they started playing?
Oh, let's see what they're talking about.
They started.
Let's see what are they talking about.
Okay.
The NFL side, yes.
Oh, I was looking at Vera Rubin's children. That's what I was doing.
Don't use too much the internet.
Well, yeah, I know, right? Okay.
Okay.
Okay, we got...
So you're talking about drinks.
Blah, blah, blah. Oh, her children all became scientists. Okay.
Good for them.
Okay. I want to know about her children. Oh, no. Okay. Okay, get out of here, Wikipedia. Okay, I don't... Gosh.
So Google has, you look shit up and then they go, people also ask, did Vera Rubin win a Nobel Prize? This is from mothersinscience.com.
Mothers in Science, okay.
Yeah. Although her discoveries is one of the most important breakthroughs in astronomy, explaining many observations that have been puzzling scientists for decades, Rubin was never awarded a Nobel Prize because of her gender, which isn't necessarily true, but also
Proponent. One of her daughters, Judith Young, she was an astronomer. Physicist, astronomer, and educator. She was born September 15th, 1952. I'm not gonna, but I know somebody with a very close birth date. But she died in 2014.
Oh, shit.
But she was the first Maria Geppert-Mayer Award for being the best young physicist in the world in 1986.
Hey.
So clearly her genes.
Wait a minute, when did she die?
In 2014.
Oh, 2 years.
Her son, Carl Cooper Rubin, is an American mathematician at University of California, Irvine. And he also was at Stanford and stuff. So that's cool. Alan Rubin, he has a research group at Princeton where he does modeling with seismic, geodetic, and laboratory observations in order to better understand the brittle ... Okay, so he works with the earth sciences. And then David Rubin, maybe he's not a scientist. Or there's multiple David Rubins. I don't know. Anyway.
David Rubin works at McDonald's.
No, it's political or something, but I don't think it was the same guy. But so that's cool.
Yeah.
That her, at least most of her offspring, I don't know, continue to follow in her footsteps and contribute to the scientific world.
She was Jewish, by the way.
Oh.
Vera Rubin. She didn't see necessarily any conflict with things, but did she follow Judaism, or was she Jewish as in she was Jewish? I think Jewish culture, but also I think she did follow Judaism.
Because if you're Jewish, there's it's more
close.
Because with your Christian, it's you're Christian.
She's hitting it.
Go away. But Judaism is more of also an ethnicity.
Right. But I do think she did follow the religion.
Oh, okay.
Or at least that's kind of what it sounded like.
And she didn't see a conflict. Amazing.
No, but yeah. I think she probably fell into the camp of religions kind of tell you kind of how you should. If the camera's shaking, it's Leia's fault. She's prancing around.
Or it's an earthquake.
Or you're going to spill your drink. Oh my gosh. Just hey, this is kind of how you should live your life kind of thing.
Mm-hmm.
But, some of these religions don't see it that way. So.
A big one. There's a big one. There's a big one with many little branches that doesn't see it.
It's the little branches. It's some of those little branches that causes. causes issues.
Mm-hmm.
You know, it's like I got into a discussion with a coworker in my department, not Brandon.
Wouldn't that be fun?
we had received a support call. It was a call,
mm-hmm.
and they wanted my colleague to log in and fix something. I don't remember what the problem was. Oh, they were playing a show and it never showed up on the dome, that kind of thing.
Mm-hmm.
And so Joe, screw this. Joe.
Well, you know, just be careful. You don't know who, you know.
Yeah, he was like, hey Mike, can you help me with this? And so I did. And so I found the problem and I let him know what the problem was. And that then proceeded this whole conversation about, you know, these people that believe that the world is 6,000 years old, and how just from a scientific perspective that they're starting they start with an endpoint and try to fill in, you know, the data. Jack, nobody wants to hear you. Dog Jack.
What are you hearing?
Dog Jack, nobody wants to hear you. Jack Northrop, everybody wants to hear you. Jack Dog, nobody wants to hear you. Go. He's like, I'm gonna go in another room, bark. But it then sparked this whole conversation briefly about, you know, the scientific method and how, you know, you don't begin with the endpoint.
No,
you start with a
question.
hypothesis. You start with the question.
You start with a question.
And that leads to a hypothesis, which then leads you to follow the science. But, you know, Vera Rubin with her quote about, hey, basically it was, I would love for it to be, you know, let's modify Newtonian physics instead of creating this, you know, having the need for this new subatomic particle. It did feel like, though, that she would follow the science, and if it was a particle, she'd be like, all right, this is what it is.
Versus, like, say, Einstein, who...
Yes. God doesn't play dice.
Wouldn't accept, you know...
Didn't accept quantum physics. And
but it's not like we would be making a new particle. That new particle would have to exist.
To be fair to Einstein, though, he did accept quantum physics. He did not accept, basically, the interpretation, what was called... the Copenhagen interpretation of quantum physics. And so basically what it boils down to is probabilistic nature of quantum physics. He didn't believe in that.
Oh, he didn't like the probability aspect.
He didn't like Schrodinger.
He didn't like how things are a little wishy-washy. Like, is the cat alive? Is it dead? It needs to be one or the other. He wanted it to be a one or the other kind of a situation.
He did not like Schrodinger's wave equation. Ironically, Schrodinger didn't like it either. He didn't like the interpretation of it. And so, okay, so if you look at Schrodinger's wave equation, which is the whole cat's alive.
The cat in the box. Cat in the box.
Yeah. It basically outlines the probabilities that something is going to happen. And so with this, you can get tunneling.
So I just realized, I don't know if this joke has been made before. I'm sure it has by somebody else. But does that mean that Gwyneth Paltrow is both alive and dead? In the box?
Yeah.
Because what's in the box?
Yeah. Alive and dead head?
That is a reference that I'm so sad that there are many of the kids, all kids today don't know what that reference is.
What was it that... we were watching something where they referenced the box in Seven. Oh, was it Jeopardy? It was Jeopardy. It was Jeopardy. It was a clue in Jeopardy where it was Seven and
that
talks about the box.
Yeah.
Yeah. What's in the box?
It's a cat.
Yeah. And it's either dead or alive. Did you bark at whatever it is you were going to bark?
He
Did
was
you come
hearing.
just
He
prancing
heard
back in here?
He heard something, and then he comes in and he gives us like a side eye.
Yeah. Yeah, I mean, yeah, quantum. I get it. I get it. It really, at the end of the day, is easier to just modify Newtonian physics.
But doesn't that mean like you have to like do all new like math?
No. What that modification is going to be really small.
Oh.
Because 1 over r squared works so well for getting us to the moon, getting spacecraft to Mars, getting it to, Neptune, all of that. And so it works too well. So the modification you're talking is a very small modification. Mm-hmm. However, it's still, at galactic scales becomes important. And
it's like when I'm doing yoga and I modify by not doing upward facing dog because that hurts my back, and I skip it and hold a plank and do downward facing dog, and that has immense proportions on my spinal health, which is not great. But
so
that is a horrible comparison. But I felt the need to make it.
It works. Sort of. Maybe not really. Anyway, so but it's much easier. It's much easier to mod it than it is to because now if you do have this dark matter particle, you now have to explain it, and you don't have
you can't explain it. You can't see it.
Right. So all right. So we figure out that there's this dark matter particle. What's it made out of? So what, and by that I mean
matière obscure.
Right. And so is it in the proton family? So does it have quarks?
Oh yeah.
If it does,
what?
How many
crime family?
Yeah. How many quarks does it have? What's its configuration? What does it look like? And so now the standard model of physics doesn't have anything for dark matter. Can the standard model of elementary particle physics be modified to include it? Well, it depends on what it's made out of, and so I mean that's
we need to get Sherlock on the case.
What?
We need to get Sherlock on the case.
Yes.
Everything's elementary to him.
Everything. And so either way, it's a rewrite.
We're rewriting something. Something has to be edited, basically. Something has to be
Physics is
textbooks at the end of the day have to be changed.
Textbooks have to be changed. And because either Newton's right or he's not.
Or he is and he isn't.
Well, technically we know that he's
right.
not completely right because Einstein came in and fixed things. But but is the standard model incorrect?
What would you think would happen if
we know the standard model is incorrect anyway.
If we could Bill and Ted things and go get Einstein and Newton and put them in a room and just have them talk it out, and then we just sit back with some drinks and watch what happens and have them just discuss the nature of the universe together. What do you think that conversation would be like? Would that be amazing?
Well, Newton had
assuming they can speak the same language.
True.
Universal translators.
Yeah, exactly. Well, we did see it in Next Generation.
Yeah.
But Newton was a shy guy, but also had a healthy sense of self. His ego was large.
He had a large ego and shy. That seems to be an oxymoron.
Well, yeah, but you can be shy and think you're correct in everything.
Yes.
So, like me.
I was gonna make the same joke, but I was gonna be like, yes, that's as I am correct all the time.
That's an interesting question. What would happen if you did have Newton and Einstein in the same room?
Oh, and Aristotle, because Aristotle's gonna be pissed.
No, but
he was wrong about probably everything.
All right, let's pretend though that Aristotle will follow the scientific method and go, okay, all right, he would pose.
Well, let's assume he's a
questions.
logical man.
I think questions would be posed, and that would make Newton and Einstein defend their position, which is really and truly kind of what it's all about. It's like a PhD dissertation; you have to defend it. But Einstein and Newton really speak the same language, which is classical deterministic physics.
Oh, okay.
And
Aristotle's like, what's physics?
But he kind of had an idea. He just didn't have a name for it. He didn't have obviously, the mathematics to back up some of his thoughts and stuff like that. But for Newton and Einstein, I think that they would. I think that Newton would see where Einstein took his physics. And I think if anybody could grasp the math behind
Newton,
it,
because
Newton
he
could probably
created calculus. I'm pretty sure he can figure out new math.
Newton could probably grasp it and see where Einstein was coming from and how Einstein was right. Now, could Newton be in the same room with Niels Bohr? Could Newton be in the same room with Schrödinger? Because Schrödinger's equation is, at its heart, a quantum physics version of Newton's laws of motion. And so, could Newton be in the same room with Schrödinger, Feynman, Niels Bohr, Heisenberg, any of these giants of quantum physics? And the answer is no, because they don't speak the same language. They don't speak the. You brought up assuming they could speak the same language.
Well, I meant like English. Or...
No. I get that. I completely understand that. But quantum and classical physics do not speak the same language.
Yes, and very different
within
hairstyles.
Physics. And different hairstyles, exactly. And so I don't think that, to me, would be the more interesting conversation. Because Newton's going to be, what about, what if, what,
But then
what,
you show Newton
how?
a video of the atom bomb going off.
I don't know. How does Newton relate to that?
He absolutely cannot.
No, he can't. He can't. He has no world experience to be able to relate to that.
That was mind blown.
Yes. So Newton's world with bombs are, cannonballs. And the little bit of tuft of dirt that it kicks up, but an atom bomb? No. Even Oppenheimer wasn't sure what was going to happen. Because remember, and I think they alluded to this, but it was actually a question, was, they thought that, hey, we might fuck up the atmosphere. Like, we might...
Light the atmosphere on fire.
Yes, exactly.
Hey, guys, we might light the atmosphere on fire, but let's give it a shot anyway.
We're going to do it anyway. Because it's remote, but, whatever. And if we do
we'll all suffocate to death together.
And if we don't ignite the atmosphere, the war will be over shortly because we got a bomb. If we ignite the atmosphere, war's over now.
Because we're all dead.
Because we're all dead.
All right.
So
cool.
Yeah.
Remember Los Alamos.
I don't think Newton would be able to have that conversation with Oppenheimer. That would be an interesting, because you just don't have the same language. Okay, Richard Feynman, great...
Look, he's got to come in with those bongos, set the mood, get everybody just feeling jazzed,
Have a little stripper in the background.
All right, someone bring in some weed. You know, get everybody chill.
Weed.
I don't know. I feel like bongos and weed go hand in hand.
Yeah, I don't think that happened.
I'm not saying it did. I'm just saying.
But
I'm setting a scene. I'm setting the vibe.
But
I'm setting the vibe.
I got you. If there's any physicists that would do weed, it would be Feynman. It would completely be Feynman. But yeah, that's a good question. It's like, what would they do? Mm-hmm. And you know,
it has no answer because you don't know.
Next generation tried to do it, and they included Hawking.
My mom says a future Einstein will figure it out. I mean, I feel like we're not due for a future Einstein for a while because it seems to be that they're just hundreds of years apart between each other for these big. Because what you got? I'm just gonna start with Copernicus. Copernicus in the. What was 1400s?
1500s?
And then you have Galileo 1600s. Newton in the
16, 17. I think Newton
and Galileo were a little bit close contemporaries.
I think Newton was born the day Galileo died.
Oh, okay.
I might be wrong.
Okay.
I might be wrong on that.
But then you have Einstein in the 1900s. So we take a big fucking gap. So at this point, with all the intelligent minds that we've had in the previous century, the 20th century, that is, being the previous century, because we're in the 21st century currently, which is not as futuristic as it should have been, given what we've been led to believe by the media, aka movies and The Fifth Element. So I mean,
we should have flying cars at this point. Anyway.
Yes, according to the Jetsons. Or
at least the floating skateboards,
the hoverboards from Back to the Future.
Yeah.
So I mean, we're talking maybe the 2100s for maybe another Einstein if we're going on a big scale of no logic that I'm just making up right now. A pattern that is not.
But it doesn't seem linear, so it does seem a little bit logarithmic. So,
I mean, things are also getting harder to discover because we do need the technology to discover the things that we need to discover.
True.
We've always needed the technology to discover things we need to discover, but the things that we're discovering now, we need even greater technology than we've needed before.
We need higher energies.
We need higher energies.
That's what we need. So
yes.
We are at a point in physics where, I hate to say this, but I'm pretty much 2 drinks in. I don't know any other way of saying this.
Do you need to take a sip? Do you need to take a sip before you?
No, I'm gonna piss. I'm gonna piss people off. I'm gonna piss.
Controversy. You heard it here first. On Cosmos, The Hangover. Phancy Physics Man's about to piss people off. I was trying to. That didn't work well. Piss people off.
I think, to me, a lot of the physics that's going on that isn't like high energy physics and things like that is mundane physics. You
just called regular physics boring.
It's not boring because you do get information from it. Is it cutting edge?
Old news? It's old news. It's old news.
Yes. Is it cutting edge? Is it cutting edge knowledge?
No, we need the colliders.
Is it knowledge that's going to advance our understanding of how the universe works? No, it is not. And it really, the atmosphere is chaotic. It is. But still, we have a general pretty good understanding of how the atmosphere works. And so, atmospheric physics, any discoveries you get, aren't going to really advance, on a fundamental level of what our universe, how it operates.
What kind of energies could we get if we had a hadron collider that was the circumference of the Earth?
Okay. Well, it's also going to be the strength of the magnets.
Okay, I don't know. I'm just saying, if we had one bigger than the one we have right now that discovered the Higgs boson, could we discover more new particles? New particles if we made one that was like planet size?
Right. So if
does it need to be planet sized?
I don't think it needs to be planet size.
Okay.
I do think.
I guess I'm thinking interferometry, where hey, you got
right. I mean, planet size is great. As long as you have the energies to be able to do it. But so let's just pretend like we get all our shit together, and
we're getting our shit together, humanity. Come on.
And we did have we put a collider out in space. And so it's a big ring that has the circumference of the Earth, 26,000 miles.
Like the halo.
Yeah. And you're just receiving all the energy from the sun that's driving this. And so it's basically kind of unlimited energy, we'll pretend.
Okay, we'll pretend. Okay.
I think you could get far enough back and recreate the energies really close to the Big Bang where you could fundamentally kind of understand what the Big Bang was. What was happening very shortly after the Big Bang.
Is there a risk? Is there a black hole risk?
I don't think there's a black hole risk.
The media says, no, these labs could make little mini black holes.
All right,
and it'll envelop the Earth and all this bullshit.
But the thing is, it's like, so you create, like if CERN had created a black hole, let's say, boom, you have this collision, it creates a black hole. That black hole doesn't have a lot of mass, and so it evaporates very quickly. Okay. And so you're going to get that with this really big thing.
You would make little mini black holes that are just like, boop, pew.
I do wonder that. I do wonder if...
that's exciting physics to me, actually.
It is. So can you look at the data and say, okay, there was a burst of gamma rays and stuff that we can't account for?
So would this kind of thing be able to then lead to a, like, oh, this is what dark matter is, like
it would give you, well, I don't know, well, maybe it would give you the data that you then have to interpret.
Right, it's all interpretation
and so,
at the end, isn't it?
So in physics, you basically have two categories. You used to have one category, now you have two.
Oh God.
Yeah, and so physics has advanced so much that you have experimentalists and you have the theoretical, the theorists.
The theorists are all in La La Land in their little dreamscapes.
Theorists like to say experimentalists are people who can't be theorists.
Well, okay, but the theorists are the ones that can't experiment then.
Exactly.
The experimentalists are at least trying to take what the fucking dreamers are thinking of and being like, all right, well, let's make this reality.
I know, right?
Let's take your pipe dreams and fucking...
So, but without the experimentalists, you can't have theorists. And so the theorists... the theorists can come up with shit all damn day long. I can come up
with a lot of things.
You can come up with shit all day long. It is the experimentalists that will sink.
They put the pedal to the metal. They put the pen to the paper.
They will either support you or they won't. And it's they may like you, but if the data's not there, then whatever. But and so So the collider will give us...
First day, I like you. Mister, I like you a lot. Look, I like you, but... The data's just not there. I'm sorry, the data... It's just not there, and we gotta have the data.
Gotta have the data.
We gotta have the data. If we don't have the data, then it's nothing.
It's not you.
It's the data. It's not you. It's the data. Insert data. Like, well...
It's actually a good shirt. It's not you.
It's not you. It's the data with a picture of data.
So anyway, you have this collider, and the collider is going to spit out a bunch of data. And
I'm just picturing data spitting out.
I know, right?
It's a fistful of datas.
Oh!
A collider full of datas.
Oh, damn. That's good.
We're getting good. These butterfly PT. Well, I'm done
I'm feeling
now.
it. I'm really feeling it. Anyway, yeah, but you need somebody to interpret that data.
Yeah.
And so that data is going to get you really close to the Big Bang. It doesn't mean that you necessarily understand it.
Yeah.
But you at least have that data there.
Yeah.
And you can say, at these energies, which were just such a fraction of a fraction of a fraction of many fractions of a second after the Big Bang, these energies existed. These were the particles that were being created. How do we interpret this? Ooh. And that's the thing.
How do you interpret it? I mean, can there be just one interpretation? Are there many interpretations?
Well,
is it like the Bible, where there's just a plethora of interpretations, apparently?
Well, yeah. There's going to be probably multiple interpretations of it. And so, all right, so creation of the universe is an example of that. And so you had Einstein come out with general theory of relativity. Mm-hmm. So just ignore everything prior to that. General theory of relativity comes out in 1917, and you had a Catholic priest, George Lemaitre, goes, okay, let's run the clock backwards. And a Catholic
Progressive priest.
Yeah, a Catholic priest is the one who came up with the Big Bang. And so you then you run it backwards and go, okay, at some point everything was collapsed in on itself. And so
everything was nothing.
And so
everything was nothing.
But everything was everything. And so there had to be this explosion of space and time.
Explosion, though. Explosion.
Yeah.
Let's just clarify that. Explosion in quotes. It's not really an explosion. Don't think a Hiroshima explosion.
This eruption of space and time that became what we call the Big Bang, leads to the universe that we see and love and know today. And so then the question is it a hot Big Bang? Is it cold Big Bang? What does this Big Bang look like?
I feel like it's pretty hot.
Yeah, and so then you have astronomers like George Gamow, who was PhD advisor to...
God, what a match.
PhD advisor to Vera Rubin.
God, little match for his fart.
Yeah. And so...
We were a god fart.
That's actually kind of funny.
Take that! Take
that!
The
belly laugh.
Take
yeah,
that, Catholics! I did.
Anyway,
I did.
You did. And so now it's on the edge, and now it's like hot Big Bang.
Poop particles all the way down.
Oh, damn. But anyway, there was still debate.
Yeah.
And you had, is it a Big Bang or is it a steady state universe? And steady state was the universe has been around forever, and as the universe expands, little particles pop up.
I feel like like a steady state universe being around forever is actually surprisingly harder for my brain, and I know that not a lot of things are harder for my brain, but harder for my brain than a Big Bang, because then it's like, but there has to be a start. If it's
right, and so,
if it's around forever,
infinities are difficult.
Except for this infinity of our love.
Right there.
Anyway.
Yeah.
You got
it. Anyway, so infinities are difficult in physics. Because that means this is where the physics breaks down.
Yeah.
You shouldn't have infinite results.
Yeah.
And so it's hard to... Okay, let me turn this around for you a little bit. So it's hard to, with steady state, go, okay, the universe is infinite. It's hard to understand that infinite.
Yeah.
Because you're like, yes, like you said, there had to be a beginning.
Right? Yeah.
Okay, so for the Big Bang... there was a beginning.
Yeah.
That makes it so much easier.
Except for
what was before the
what
Big
was
Bang.
before the fucking Big Bang.
And
That's when my brain then just starts, like, I feel it trickling out my ears. I can feel it coming down my nose.
yeah,
I get a little sniffly.
It just,
I get a little sniffly, and it's just, it's an Egyptian mummification process that I begin to experience. Minus the tweezers pulling my brain out. It's just a natural melting of the brain out my nose and ears, and whatever other orifices the brain's going to come out of.
yeah, so, both of them have
a what the fuck?
Exactly. And so, even with the Big Bang, it is like what caused it. Mm-hmm. But to be fair to physics right now, physics doesn't give a shit.
Fair with a PH.
Physics doesn't care what happened.
Well, no.
Prior.
Only humans do.
Because that is not part of this universe. Mm-hmm. That is not that was before this universe. It's not necessarily governed by the laws of physics.
It doesn't carry that baggage.
Right.
It's not my baggage.
We are living under now.
Mm-hmm.
We are making the assumption that laws of physics are the same no matter where they are in the universe.
But in this universe, yes. But
in
what about
universes.
second universe?
Right. Oh.
Well, no, we don't drink during the hammer.
But it's but now we have advanced to the point where we can actually start asking those questions. What was prior to the Big Bang? And what was prior
to what was prior to 10 to the negative 34 or whatever it is? 32
yeah, and that actually
seconds.
Big Bang. No, what is prior to time zero? Zero is when the Big Bang happened.
Right. But physics can explain everything up to 10 times
minus 42.
Minus 42 or 32?
The best that we would be able
42
to do... 42
would be very convenient.
The best that we can do is the Planck link, which I think is 42.
Okay, I thought it... Jackie, stop. I thought it was 32 or 36 or something.
But we're not at that point yet.
Yeah.
I don't think. And so
Oh, careful. But you bumped the nightstand.
I did. That would have been actually kind of funny. Especially if I had to
end table or whatever it's called.
All right, go lie down, guys. Anyway.
You're fine.
So
I gotta sneeze again.
Bless you.
Okay, I'm back.
All right. We can edit this out.
No, I'm not gonna. I'm too lazy to edit anything.
So we just need the energies.
We need the energies, but these energies that we need are energies we can't get currently.
Well, I'm right. So these are really high energies that CERN's pulling. But we are also, nothing happens in a vacuum,
but all of space happens in a vacuum.
But not really. So vacuums are just full of virtual particles and energy and all this kind of stuff.
I mean, yeah, look at our vacuum. It's just all
nothing in the vacuum. So what? And you can't make this statement without politicizing it, but...
Space can be politicized?
Huh?
Space can be politicized?
Well, physics can. And so with CERN, if we didn't have to worry about what's going on in Ukraine, what's going on in the Middle East...
Before you make the statement, I wanna make sure that you are certain.
Okay. It's a good thing I love you.
Continue. You may continue now.
Our commitments are all out of whack.
Well.
And so...
when have they not been?
True, but, it's... If arts and sciences were more important, then we could find the money for this.
All the English teachers just got real pissed at you.
That's arts. That's arts.
Is it?
Yeah,
It's
I mean,
English.
okay, so no, I'm not just talking about drawing pictures with arts. I'm talking about, plays, books,
Oh, okay.
pictures. So art, like actual
Right.
what we think of art
Uh-huh.
sometimes. Sculpture. So all of
Right.
that kind of part of humanity.
Mm-hmm.
But also the scientific part. But
Mm-hmm.
what are we fucking doing? We're worrying about,
Who
fighting
we
wars.
like best, personality-wise, as president.
Right, we're fighting wars,
Mm-hmm.
um,
Look,
and
the God Gold Glory concept has not left our paradigm.
if the Vulcans would hurry up and land.
We can't. They can't. They're like, look at these dumbasses. We can't. They're not ready yet. They're
So
They're toddlers. They're toddlers with atomic weapons, is what they are.
true.
Let's
Very
hope
true.
they don't become toddlers with a warp drive.
Yeah. So, but if the Vulcans were to land, and we were living the Star Trek universe, we
Uh-huh.
could learn this stuff. We could do this stuff. We could learn it, and we would have the available.
There
energies.
are Vulcans, a Vulcan-esque species that has learned this and can learn this, because is it physically possible? Is there a physical possibility of warp drive? No. Oh, that's a myth, Mom. We have all access to 100% of our brain.
Yeah.
That 10% of the brain we're not accessing, that was debunked.
Well, warp drive, NASA is looking into it, and there was a Mexican physicist who this is how you do it.
Oh.
Now, okay.
Oh.
The caveat is that you need exotic material.
And
to
that
do it.
exotic material, just like dark matter and dark energy. We don't know what it is, but you
Exactly.
gotta have it. We gotta have it.
So what the physicist said was that locally you're not going faster than the speed of light. Locally you're going 10 miles an hour.
Mm-hmm.
Maybe even just fucking sitting still. Who knows? No, you're going 10 miles an hour, let's say. But you contract space in front of you and you expand it behind you. But to do that, you need exotic material. And when physicists use terms like exotic material, it's like dark matter, dark energy.
it's like
it means that
something we don't have.
something that I mean, you really might as well put dark matter in there, because it's the same explanation where it is. It's not protons and neutrons and electrons.
Something else we don't know, but we need it.
We don't know what it is, but you fucking need it.
I like Jack's comment, Vulcans lock the doors flying through the solar system. We're the space hood.
Yeah. Oh my god.
Careful with those humans. We're like the but not as cute, the tribbles, but not as cute, but we just, once you get us, oh god.
Yeah, didn't Strange New Worlds have triples?
They did
did
They did an homage to tribbles. They did. Yeah. You know what? We did a lot of deeper thinking stuff than I thought we were going to, and it was actually really exciting and really fun to kind of talk about.
And with that, I think Jack is saying goodbye.
Yeah, I think he's saying that Liz needs to go. Damn it! What was the term? Liquid drop.
All right, everybody, we're gonna go liquid drop. Cheers, everybody. We'll see you in 2 weeks. Join us in 2 weeks for
High in the Sky for March, because we're almost in March.
That is.
Can you believe it? How time works? I don't.
I want time to slow down.
But it can. It just keeps. It just is. It's.
No,
it's also. It's a. Well, I mean, it's a construct. So if you want to slow it, just slow it down.
Okay.
You just got to get everyone else to agree with you.
Now I have to respond to my sister's future-in-law husband, future husband just sent me a text. I'm like, oh my god. I have a question or two. Oh god, I need more drinks. Anyway, cheers everybody. We'll see you in 2 weeks for What's Up in March. Everybody stay safe, stay healthy. Look to the skies if it's clear. Look to the skies if not. Go to your local planetariums. Cheers.
Bye, everybody.
Bye.
And bye.